So here it is now, you can hear it running. There's the oscillator, and there's about 2 volts of capacitor power running it. So right now I'm shorting the gap because it's low voltage mode using the coil. Here's the Electret, and this is the meter timed out. Okay, so this is the voltage of the Captret, and it goes up to about 500 half a volt, and then triggers the PCB Joule Thief, and instead of an LED it's a diode which charges the capacitor. So as you see, it's always rising, and then when it reaches a certain threshold it dumps it in there, and then this runs the high frequency. So it's using the ambient and cycling its own power in part to keep it going, and it's working for pretty long. So it's saying about 1.7 volts. I'm going to try and record it and see how long before it craps out here, and like self-oscillating with just capacitors and coils and oscillators. So here's that charge I was talking about. It keeps building up, and then it dumps it in high voltage for about 20 seconds, and then it stops because it goes low again, and then it slowly builds up from the cap thread here. And here's the coil. It goes under here, the metal part. And here's that high frequency coil I was talking about, rectifying and sending it in part back on the regular 346.2. You can hear the oscillator. So now 2 minutes and 30 seconds. This is not a trick, by the way, it's just my voltmeter wires. There's nothing there. I'll just screw it up there. I just want to show you there's nothing under the table. So now we're at 3 minutes. So this is basically the high frequency against the ambient, charging up the Electret. I have a hard time with that. Almost the same thing. Captret. You can still hear the oscillator. That's the high frequency source. It's a little messy, I know, my apologies. That's the wonders of experimentation. Oh, 4 minutes and 50. There's the oscillator. You could really hear it, the high frequency tone. Oh, it just pulsed, you can hear it. So now we're a little lower, I think. It's recharging back up, building its 500. Because I hear it speed up a little bit when this oscillator kicks in here for a few moments as it kicks the charge back in. So 5 minutes and it's still oscillating with capacitors and coils. So at the very least we can say it's an efficient circuit for now. But again, it's not tuned, it's just to I just want to experiment with the effects of the Electret to see if it has any applicable usage here. I don't know if it does or not, if this is worthwhile pursuing, because that's not the main intent here of what I want to do with this coil. But I just wanted to experiment at low voltages to see what I would get, the high frequency against the low. Basically, that this scalar charging community from the internet has all these circuits about the scalar waves and whatnot. So let's see if there's a half-truth in all of this. The Electret seems to be doing its thing, But with the help of the high-frequency oscillator, when I turn the high-frequency oscillator, this number just drops. No charging up, so. So now we're at 7 minutes self-oscillation. I wonder what the record is for an LC circuit to, cycle on its own. Well, this is several LC circuits, but essentially this is all what it is. Just in a very unique and strange configuration. I guess you could even look at the separate grounds as a type of coil at high frequency, like they do in VLF. Here's the oscillator. The Electret's still charging. Ground is still the cold water pipe on one side, and my coax from my ham radio antenna on the other here. Eight minutes of oscillating, and the Electret is still, sorry about that, the Captret. Because I'm used to Electret because of the way I played with coax before. You can hear the oscillator. Yes, this Electret is a really big capacitor, 2 farads basically. I didn't think it was going to work, but that's all I had that was significant. It doesn't have, well, it's not bad. It handles a maximum of 40 volts, I think it says, or 30, what is it, 36? No, 40 volts. But we're not using anywhere near that much because, with the Joule Thief, it hits a threshold and sends the pulse back to here, these smaller ones here. So are we now? 388 points. Slowly rising, but it rises. But that's what it does when it hits a certain threshold. This, for a moment, maybe 20 seconds, high voltage, spikes in here. So now we're at 10 minutes. 10 minutes and 50 seconds. And we're still oscillating, which is pretty cool. I could hear it. It's going to clonk out soon, I suppose, because like I said, I haven't tuned this. I'm not optimizing it. I don't have really good antennas. But perhaps just this idea done better could self-sustain forever. I don't know what the usage or the application for this, but it's just too insignificant, other than perhaps proving a concept, a point, experimenting with Electrets, with the coils, interesting LC circuits after LC circuit. This is where my spark gap would be, but I'm shorted out or touching because it's sending the low voltage, high frequency. Got a little bit over 1 volt in there. But it doesn't seem to really affect the charging rate of the Electret, as long as there's a pulse going on. The Electret. Here I am again. The Captret. As long as there's a high frequency pulse, it my apologies. It doesn't seem to care very much. "13 minutes now." You know, this is pretty cool because, you know, when you usually do the oscillations with the tuned LC circuits, and you see that it's like a skipping like a rock, where you got the wave and then it dies down right away, you know. Oh, there's definitely a slope here of down, but what I'm trying to get at it is it's not narrow, you know. It's taking its time, but usually would take, you know, 13 seconds or less on the typical LC circuit. This is taking 14 minutes now. So I would say there's definitely help, whether it's coming from the scalar or the low frequency, the high frequency, a mix of all the above, the effects from the Electret. You mix all of this into the, there you go, 400. I'm going to get a discharge again pretty soon, believe it or not. So we're at 14 minutes now, and we're still driving the circuit here with its own, whatever it is it's doing. Maybe someone could explain it better than I can. My voltmeter is actually timing out here. It's been so long. Are we still oscillating? Yes, we are. I can hear it. Much lower than the original, and we're down to 1 volt now. However, it's still pulsing, and it's hasn't really affected the rate of the Electret. I still like driving bigger things with it, like a special high frequency AC motor, so I could eventually run a generator and use the power for practical usage. But I think we're still some ways from there yet, but one experiment at a time. .3, we're still 15 minutes. The oscillator is still pretty weak. It's almost done. I'll know right away because this will start going the other way. It's gonna start going down because the Joule Thief will run and then it won't have any more recharging, and you'll see it drop to like 200 and it won't sustain no more. That's my way of, finding out if it's working or not without hooking up a scope to it. No pulsing, no generation apparently. So I was hoping maybe this is basically the idea of instead of using the ambient to drive it, an external source, but I thought maybe the external source could be micro as well, as long as it's high frequency. I don't know, does that make any sense? I don't know, but it's doing something. So we're at 16 minutes now. Wow. 16 minutes. No, 17 minutes. Too bad there's no records on the longest running LC circuit. Self-oscillating mode. I'd probably win it with a bit of tweaking. For whatever it's worth. 17 minutes. And let's see. I'm gonna get another discharge very soon. And I can still hear it. Probably the camera won't hear it no more, but my ear can still hear it. Because we're down to about a volt. But however, it's still pulsing at high frequency. So that could be like, I haven't really measured it, but that could be like even 12 volts of high frequency pulses. I'm running out of equipment. I don't have a voltmeter for every stage of the circuit. Unfortunately, I have to choose which ones I feel are more relevant to monitor. Because if I had I'd have an amp meter on every freaking wire if I could. But that would probably screw everything up. 18 minutes now. 18 minutes. So yeah, there's definitely, I would say, yeah. It's a very efficient circuit. A very efficient oscillator right now in this mode. 409.3. See if I can still hear it. Hardly. But I've got about 800, almost a volt, still pulsing. Won't be for long though. I could end it, and I probably will, just to end the video, so I will show you. See, this is rising here. So this is the power here which controls the oscillator, the high frequency. This is the negative, so I'm gonna take it off now, if I can, like this. It's hard doing this with one hand. There you go, it's off. See, no more high frequency. And look what's happening here. See how quick it's dropping? That's just to prove to you that even though you weren't hearing it anymore, this was still doing the job. It was pulsing high frequency. But the moment I stopped, see, we're at 19 minutes. This could have ran for probably another half hour. But just to end this video here, because it's been like 19 minutes, I want to show you. But just for the kick of it, if I want to put it on, I don't know if it's going to start back. I'm going to hold it with my hand here. See what's going on? I'm holding it. And now all the cap thread is charging again. So there's still life left in all of this, believe it or not. So you see, I put a complete stop to it, and I was able to start it up again. And we're like at 20 minutes, you know? And this is going to hit eventually 500, and it's going to keep doing its thing. It's going to drive the PCB joule thief, which is going to charge these. And then those capacitors are going to discharge a low voltage to the high frequency oscillator. So yeah, this could run a long time. I'm basically choosing to end it now, but as you see, I don't know, I guess there's obvious, I'm saying it's going to stop because obviously I haven't fine-tuned it or anything, and I see the voltage eventually dropping here, but it doesn't need much to cycle this oscillator as a whole here, and the Electret is still charging, but I have things to do and I have other experiments to try. So again, I'm just making a note that I'm choosing to end it now. I don't want to hold this no more, so I'm cutting the high frequency oscillator, and this is discharging now. That's because the circuit is no longer producing a high frequency. It's just to show you how that is such a crucial part of all of this circuit, is the high frequency drive. And if this means anything, it doesn't have to be a very strong one. But it might not be applicable for anything. We might have to use the high voltage spark gap like I did originally to drive bigger, you know, high frequency AC motors to actually make them spin. This is not quite the same idea. I just wanted to build a super duper LC circuit in self-oscillating mode. So as you see now, there's nothing going on. It's just the residual of the Electret. I still got the voltmeter on, so it's going to eventually go down to maybe, I don't know, 50 or so and stay around there until I start this over.